Hi.
Hello, can you hear me?
Yeah, better.
Okay, great.
Hello.
Hey.
How's it going? Good.
Okay, it looks like we have Ian and Ilya, so I guess we can get started. Let me present the agenda. All right, so this week we're just going to go over some failover benchmark results from Ian and some HTTP API benchmark results from Ilya. Before that, I was just going to give an update on some of the optimizations to protobuf message handlers and defer and dispatch in the process. Dimitri, who was working on those, it looks like he's not in the call, so I'll just describe what's being done. So the first thing was that we added support for arenas, and we started making use of those in the install handlers in the process where we're taking const messages. So that just provides a bit of an optimization there. And the second thing was there's some upcoming work to basically do copy elimination in defer and dispatch. So we want to support moving into defer and dispatch. Dimitri and Michael were going to work on that. So yeah, that's about all that's happening there. Does anyone have any questions about that?
Move support, okay.
Yeah, the goal there was to focus first on master failover, where we're copying all the protobuf information that the agents are telling us across the continuations. So we want to instead just not be doing any copying at all there.
Right. I was going to mention Dimitri's previously committed work, but I guess it's already talking about
yeah. So
in the previous one, sure. Which I didn't attend, so.
Yeah, so I think he's got it down to maybe 1 at this point. When you're going across a dot then that uses defer, but we'd like to make that 0. So I can stop sharing my screen. Do you have some content, Ian? Or do you just want to discuss it?
No. Go ahead.
Okay. So sorry, was that no that you had no content or?
Oh, I'm sorry. I thought I wasn't muted. No. Oh, are you? I'm sorry. Are we moving on to the second item on the list, or? Oh, okay. I see. Um, I don't have. Okay, I don't have a screen sharing to share. I just have a status update.
Okay.
So I basically put together some benchmark for the agent registration this week, and the result hasn't been conclusive, but I think it's a good start. We can. I have a whip which I can share shortly after. I guess I can gather some feedback here by just talking about it briefly. So the benchmark is basically having a real master with a bunch of fake agents, which because even for a full-fledged mock slave class, it would involve a lot of states recovering and complexity there. So basically what I've done is just to create a protobot process, which is called a test slave, which does only two things. One, it can send read register message to the master, and it's installing a handler for slave re-registered message, so it knows to respond to the master's re-registered message, and when it receives that, it basically marks the future as finished, as ready. So in this way, we're basically simulating for example, 2,000 or 20,000 agents re-registering and all calling the master at the same time, which is obviously a little bit different than the real-world use case, but without randomized backoff. This is arguably more deterministic. So it basically just measures the time the master has received the re-registered slave message, which also is a little bit different than because all of the actors are within the same process, which is a little bit, so in terms of performance characteristics, a little bit different than what you will really do when you send this from different hosts. But at least this captures the path from that point on to the next couple of asynchronous processing steps where it consults the authorizer and registry, for example, and then does handle processing all of the state sent over by re-register slave message. So it captures all of that. So right now the knobs are the number of agents to re-register with the master, and then just try to simulate what the real slave has done. There's the real agent captures a number of a number of frameworks on this agent, and there are tasks running on these running from these frameworks, and also there are completed frameworks, and there are tasks history including completed tasks. So per host, I'm giving 5 frameworks, and for each of these framework, I give 5 tasks, and also I give 50 completed frameworks, and I give 5 tasks per these completed frameworks. So just a few simple knobs to simulate the behavior. So far, the result hasn't been all that, great.
Hello, just one question. You said you're simulating the behavior. Can you describe exactly the behavior that you're trying to simulate, like the scenario that you're simulating here?
Right. Just so first you have a master, and then I create, thousands or tens of thousands of agents. These were like fake agents, which are basically just actors I created to simulate the slave object. And by simulation, I mean it will, when I create it, it will send a re-register slave message to the master, all of them, without the real backoff and all that, without retries. It would just send all of these messages. But these messages are big, right? So they have all of the states from the agent. So
I followed that part. I was trying to understand the number. You like 50 frameworks with 5 tasks. What are those tasks running, or is it one task status update per task or something? I didn't get the scenario of the scheduler behavior.
So when re-register happens, there's no task updates. There's just a task status, right? So the math would come up to 250 running tasks and 250 completed tasks.
Yeah, I think currently the point is there's no frameworks involved in your benchmark, right? It's just about agent.
Right.
Re-registering all the agents and how fast that happens.
Yeah. That's
okay.
That's the first draft.
Thanks, Ben.
But I have run this, and the number I got is, so for these numbers, so for example, 2,000 agents and probably 500 tasks per host. But the caveat is I create new frameworks. Distinct frameworks for these per agent, so that I don't cross-sharing frameworks from them. So,
are they all in separate roles, or is it the same?
No, just the basic default framework info, everything the same. Just as a simplest scenario you can think of, and it takes a minute. For the master to finish, and a minute is measured by the time I spent on creating these messages is also included, just because I send them over when I finish creating them. So that's lumped together. But the master would process these, and eventually the master would send a slave re-registered message. And when the slave actor, the test slave actor, receives that message, it's going to mark a future as being completed. So I basically have, for 2,000 agents, I have 2,000 futures. I'm doing a weight on all 2,000 of them. and I stopped watch once that all of the futures are completed. So that's the measurement, and it took a minute to re-register to fully process all of these, and I cannot see any difference between the version basically is the head versus the version before Dimitri's first defer patch. So I'm guessing.
Did you do any analysis on it? Did you get flame graphs or any perf data?
No, I haven't, which I could totally do. But so with flame graphs, I think offline I told Ben that our environment has some problems, which basically I tried to generate flame graphs from our production systems, but the graph came out with the whole bunch of unknown symbols. We know what is the problem, but then right now we cannot fix it. But still, flame graph seems to me can only tell you this much, because previously even with that graph with whole bunch of unknown symbols, we could see protobuf processing being a very wide bar. So I guess it is a known fact that these copying or constructing is taking a lot of cycles. I guess to derive meaningful result from there, unless I see that bar to be dramatically reduced, then I will capture a flame graph on my benchmark tests, and I will share the results. But at this point, I'm not sure how I would interpret that result.
I had a quick question. This is the first time I've attended one of these, so I'm probably missing a bunch of context. But what is the context for this study? Was there some behavior you observed in your you're registering 2,000 or 20,000 agents? Were you seeing slow agent registration, and that's what motivated the trying to figure out what's slow? Is that what's going on?
Right. So we have already done a bunch of optimization, which improved the failover time drastically. But previously, so what motivated this from the very beginning was when the master fails over, the agent would all start reconnecting, re-registering, but it would take sometimes a very long time for them to be fully re-registered.
I see. Thanks.
And when you register agents, do they just send one request, or they try to send lots of them before they receive acknowledge?
Right. So in this benchmark, so that's why I'm open for feedback. But in this version, each agent would just send one registered slave message and wait for the response, which is the slave re-registered message. It wouldn't do backoff. It doesn't do retries. One, because I found it simpler to create a basically new fake slave object, and which has the logic to do all of these. If I add all of these mentioned things, I have to add a whole bunch of logic in there. But two, I'm not sure whether that's going to help us gauging the performance of the master, and that's certainly not possible to recreate 100% real scenario from the real use case, right? So,
So
I don't know
when
whether this setup makes sense to you. Do you think at the minimum some more elements should be added?
well, the possible addition is retries, I think. But when I was testing my patch, it's basically not the code that is in the master, because there are a few things missing, like moves to defer. Then there was vector optimization, vector conversion optimization. I mean, when we convert repeated Peter field to vector, this patch is not there. And another one was moving data from messages to handler. That's what Ben was talking about in the beginning. So that patch with moves optimization inside defer or inside fuses, that's not all of it.
It's not relevant?
No, it's not. It's not all of it. I mean,
It's not all of it.
my tests included like all three, and in master there's just this one. So maybe that's because you didn't see significant difference in performance when you compared current head and the version before the patches.
Okay, I thought because even if we're sending, even if the agents are in the same process as the master, at least the protobuf handlers, and from the handler to the message, the method that actually handles it, and from that point on to all of the subsequent differs, they are still all happening, right?
Yep.
So, right, I was expecting some improvements there, but
I think a great improvement was from optimizing conversion from repeated field to vector, but it's not committed.
oh, it's not committed. Okay.
Yeah, that what happened in that patch was instead of using arenas, we construct a message on the stack and we move into the vector for repeated fields. But I think what we'll do there is just have move support for moving the whole message into the handler to accomplish the same thing. So we'll have that at some point, but we don't have it yet.
Okay.
But yeah, I mean, it would be great if you could gather some performance analysis information and share that with the list, and maybe at the next meeting present it.
Right.
One
Okay.
question: did you increase the number of threads in pool? Because I guess with default value there will be just few processes competing for processor time.
I didn't. So the number of threads I am using is 32. We have 32 cores. But it seems to me it's going to be a large number of idling actors, which are sending messages and then waiting. And then it's just going to be this master, which has like a very large backlog, and it's processing off of. Do you think in this scenario the number of threads would make a difference?
Maybe not. I'm just thinking that when you launch lots of agents and basically all the threads are busy with filling that backlog filling the queue for the master. And
yeah, I think like one question here, Ian, is like, how ready are your agents when you start the benchmark? Have they already constructed the message they're going to send and all that? Or are you doing that as part of once the benchmark starts?
I'm doing that after I start the clock. So
Okay.
I could pre-construct all the messages and then start the clock and then send them.
Maybe the better option would be just push all the messages to master queue and then just run it alone.
And push to master queue and then what?
Just run the master. Like the only one thread would be running. Like you construct the messages, then push them, like message event, you inject that to master queue. And then like when everything is constructed, you just let it run.
Right, yeah, that's basically prepare the messages first without running the clock, right? Sure.
Okay. I think we're almost halfway, so maybe we can switch over to Ilya. Ilya, did you have some content for the HP API benchmarks?
Yeah, I have some numbers to show.
Okay.
Let me share my screen. Okay. So what I did, I created two benchmarks that their purpose was to compare the performance of the old libprocess message passing based scheduler driver and the new V1 scheduler HTTP API. For the implementation of those benchmarks, I used the old HTTP, the old libprocess based driver that all frameworks are using right now, and the new HTTP based V1 scheduler driver that's called Mesos. So because those benchmarking tools are using the process and parts of the Mesos, the performance of those benchmarking tools affects the benchmarks as well. So I used the latest version available, which is at this time 1.4, and I compared the performance in two scenarios. First scenario is when the master is generating a lot of events. For this benchmark, I send one huge reconcile call that contains a lot of non-existing tasks, and for all of those tasks, the master will respond with an update event. And I measure the time that passed from sending the call and until the last update event that the scheduler receives. The other scenario is ingesting a lot of scheduler calls by the master. For this test, I sent many revive calls. I chose revive because their processing is relatively cheap, so it won't affect the test that much. And after I send all the revive calls that I had, I'll send one reconcile call with one non-existent task. I do that so that an update event that the master generates in response to that call will designate the end of the processing of revive calls that I sent previously. And in this benchmark, I measure the time that passed from sending the first revive call to receiving the update event. So some results. For the first benchmark that measures measures the performance of sending of many events by the master, the performance is roughly the same. So reconciling 100,000 of tasks takes roughly 6.4 seconds if we are using the old scheduler driver, and it takes around 6 seconds if we use the new HTTP scheduler driver. So as you can see, the performance is somehow even better.
Just a quick question.
Yeah.
How exactly are you counting that time?
I start the clock when I'm ready to send the first call, the update call, and I stop the timer when I receive the update event.
The last one?
Yeah, the last one.
Okay.
Yeah, one interesting thing that I found when doing this benchmark is that right now the HTTP scheduler driver calls the received callback in an asynchronous manner. And interesting thing that if we switch to the synchronous calling of that callback, we gain roughly 40% performance improvement. As you can see in this benchmark, the time that took to process the same amount of reconcile calls is 3.7 seconds.
So that would be an optimization to the C++ scheduler library for the V1. Okay.
Yeah, exactly. So in this scenario, I think the new scheduler driver is good. So move to the second benchmark that measures the performance of call ingestion. And here the results are not that good because when we are using the new HTTP scheduler driver, the performance of it is nearly 3 times worse than if we use the old libprocess-based driver. If we see the numbers, when we use the libprocess driver, it takes 6 seconds to ingest 100,000 of revive calls, and with an HTTP driver, it takes 18 seconds. One of the things that affect the performance that I found is the authentication code in libprocess, particularly in the process base visit continuation. What it does, it tries to perform to run the authentication stuff on every HTTP call that libprocess process gets. And if we disable that part, we gain like 40% performance improvement, but the performance still won't be as good as the old libprocess driver. I think that if we speak about the new HTTP scheduler API, we don't need to run authentication for every call that the scheduler does, because when the scheduler subscribes, it can authenticate, and after that, the scheduler gets a stream ID from the master, and this stream ID acts as a session identifier. We don't need to authenticate any subsequent call after subscribing. So
yeah, we had there's definitely a to do per connection authentication rather than per request, but yeah, it's not there right now.
Yeah, so there is some field for optimization. Yeah, that's what I found, what we can work on in terms of the performance of the HTTP API. I did some profiling with perf. I have some flame graphs for the master and for benchmarking tools, but unfortunately, nothing stands out if you look at these flame graphs. Unfortunately, besides this thing where sim weight takes like almost 30% of the time.
Just a couple questions. Did you build this with optimizations on or off?
Yeah, of course.
On or
on?
Okay, and did you use the lock-free event queue or?
No,
okay.
I use just the default.
Okay. Yeah, it might be worth enabling the lock-free event queue and lock-free run queue to see if that helps at all. So it looks like this is essentially run queue locking this section from what I can tell.
Yeah.
So yeah, it might be worth trying that out and seeing.
Yeah.
What
so
about
that's what I have for today.
Are the other graphs similar or?
Yeah, they look similar. This is, for example, for the master when we are using the lib process driver. It looks relatively the same. This thing stands out, but now it takes 55% of the time.
Okay.
Yeah.
I'm just taking some notes. Could you put the link to your doc in the agenda?
Sure.
Okay, yeah, that was it for today. Are there any other topics people want to bring up?
Well, I guess while I'm here, I would like to figure out what Dimitri wants to do with the defer dispatch stuff. We're essentially, like, the context I have is just that we want to move the arguments through defer and dispatch. Is there scheduled work or investigation going on? Or anything else?
I just briefly looked at the code and just that.
Okay, so would you like me to drive that work?
Well, if you can share ideas that you have, that would be useful.
Okay, all right. I'll reach out to you on Slack, I guess, Dimitri. I guess essentially what we want, though, I think first we need to build a one-shot bind utility, right? As you mentioned, like std bind doesn't work for us because it assumes that it can be called multiple times. So we can kind of build the one-shot bind utility in isolation somewhere in Stout. And then we can use that in the process to make sure we move the arguments through properly. The other thing is that I think we should do some research to make sure that underscore deferred actually doesn't ever get called more than once. It shouldn't be. It shouldn't, but we make mistakes. So. And then there's some refactoring work that I would like to do for deferred as well.
By the way, are we moving to C++ 14?
Yeah, so what I want to do there first is the CI is pretty unstable at this point, and I have people who don't want me to upgrade to C++ 14 just yet because we want to stabilize the CI first. I'm not sure how long that's going to take. But the other thing is that we actually need to update the CI to begin with to have support for the new compilers, because otherwise it's just going to break everything. So there's already some work to be done
So the CI instability is just referring to the flaky tests?
I think there are more than some flaky tests.
Okay.
There are like how many, like 30, 40 flaky tests that are failing relatively consistently. Probably more.
And people add them every day.
Like yeah. So from what I'm hearing, there's more than 40 tests that fail relatively consistently, flakily, but whatever. It's like we're not in a good state with the CI right now. So, but yes, in short, yes, we I do want to move to 14. There's just some resistance today. Do you think that would? I mean, we would still need to build a bind thingy, right? With 14, Mitri?
Yeah, I'm just thinking that maybe 14 would be
simpler.
Or simpler.
Yeah, I agree. Okay. Yeah, maybe then you and I can kind of.
So, hey, Ampart.
Yeah.
So, how are you thinking about trying to guarantee that this is only going to get invoked once?
I was mainly just thinking about just looking at how things like where and how it's called. Like for example, we presumably, take the result of defer and pass it to then, right? So we should look at the then code to make sure that we actually do only call it once and that kind of stuff.
I almost wonder if we want to introduce like some type, where we move the type checking basically into the runtime, like a call once function.
Right. Yeah, we could probably do some runtime checking to get some confidence that it's only being called once all the time.
Well, by things like future then, if they take a called once function or a deferred once, whatever it is, then that's basically exposing in the API, hey, we're guaranteeing that if you give this thing, we're only going to invoke it once. And then it's on us if we invoke it multiple times. So we shouldn't, because we're basically encoding that in the type.
I mean, isn't it always on us to call it only once?
Yeah, it is always on us, but I'm just saying that's basically, I think that would be a sane way to think about it is if someone creates a called once or a deferred once function, and we will move your arguments into it. Now, I want to be clear, we can't move the future arguments itself. We can't move the future value. That one we still have to pass as an L value reference. Because there could be multiple people that hold on to future. So the only arguments we can move in are like the other things that you might be binding at the time of creating that once callable, which you want to get moved through, which you couldn't do with a standard, with a stood bind. Does that make sense?
I mean, I think so. We don't want to move everything just because we're only going to call it once, though.
Right. I was just implying the things that people explicitly move into us, we could move once we actually invoke.
We're all blocked. Is that what you're going to do?
I'm going to a zombie.
Hey, Ian, can you mute?
Huh?
I was just telling Ian to mute.
Well, it's not from me, but I will mute.
Okay.
That might be me. Okay. Okay, so, but you're not suggesting to introduce a deferred once function, right, Ben?
Well, what I was basically suggesting was we introduce a kind of bind which is typed as something which is basically like, you can only move this thing, and once it gets someplace and someone wants to hold on to it, the runtime contract is they'll only execute it once. And
do we have places where people are holding on to the result, the like underscore deferred?
Well, we end up holding on to the stood function inside of future that we ultimately execute. Like it gets implicitly converted basically to a stood function, and then
Okay.
so this would be like if somebody gives us a callable once or whatever it is, and the idea is under the covers when that gets executed, we could move through, I guess, any parameters that pass to it.
Yeah.
But what I was just saying is we can't move the actual underlying future value, because if someone does multiple dot thens on the same future, not a chain of dot then, but literally just the same future, and they pass two different callable onces, the first one that would go, if we moved it, that means you couldn't call the second one. So I think there needs to be something completely different if we want to have the concept of I have basically a future that nobody else has, i.e. I have like the R value of this future and nobody else has it. And there's no other copies of it. Call it like an owned future if you want, or unique future. And therefore, when I pass my callable once to a unique future, I can also guarantee that that when somebody, I can also then guarantee that I can move the value out of that unique future into the lambda. But that's just so much trickier, because basically, if someone calls dot then, all of a sudden under the covers, this unique future can, like, you can no longer call dot then on it again. You can no longer call dot on any on it. Like you can't call like dot on ready. You can't do any of these things. So that's the case that I think is going to be much trickier. And in the short term, if we find places where that's a performance issue, I think we should solve that by basically passing shared pointers or unique pointers through the futures.
Yeah, I get what you're saying. I think, yeah, I mean, the problem essentially is just that futures are inherently shared, and so we have the same problem as like stood bind, where we have to be able to call it multiple times. Essentially, calling dot then multiple times on it you can't move it into the then, because we have to be able to do that multiple times.
Exactly.
My understanding was we're not trying to move the future value through, but rather the arguments that kind of travel along with it.
Right. Yep. I agree. I just wanted to clarify that one point.
Got it.
Yeah.
Okay. All right. Okay. Yeah. So I'll chat with Alex about what we should do about C++ 14. If we can do that sooner rather than later, I would be happy. But I also don't want to, shake the CI even more. So.
I just wanted to get a clear standing on so when this planned work is done, and like you said, to move the arguments that comes along with the future, then in many of our typical handling message handling methods, we're like doing partial processing, and then at the end of it, basically more often than not at the end of it, because we need to invoke another asynchronous component, we jump out of the current actor and go to another, and then later come back. So does it mean that then for a lot of these arguments, we'll just do standard move on all of them? If they're not shared, they're just parameters within the scope of the method. We're just going to move standard move on all of them. So, and then the process is going to process them with the move semantics, and then we basically don't spend any time copying these things.
Right.
But you have to identify these movable things and put standard move on all of them. I see.
I mean, you could also, like, the idea is that you wouldn't be copying the tasks, for example, that come in from the message when the agent's re-registering. You'd just be moving them across the asynchronous context and then ideally moving them into the master storage as well.
Right. So all the way from the initial protobuf.
Yeah.
Right. Yeah. Okay. Yeah, that sounds great.
Of course, it would be good to see some performance data from your benchmark to see how much that's actually contributing, but it'll be an improvement. So.
Okay.
Yeah.
All right. Anything else? Going once. All right. I guess we'll end early. Thanks, Ian and Ilya, for presenting stuff. Yeah, I'm looking forward to starting to make some improvements based on those benchmarks.
Great. Okay.
Cool. Thanks.
Thanks, guys.
All right. See ya.
Bye-bye.